Okay, here's number 3 on 7.1. We got our velocity function v of t equals 49 minus 9.8. And again, our interval is going to be 0 less than or equal to t less than or equal to 10. So first of all, we want to find out when the particle is moving right, left, or 0. So this is the A. So in order to find where it stops, v of t equals 0. So I can say 49 minus 9.8t equals 0. And I end up with 49 equals 9.8t. And if I divide both sides, I get t equals 49 divided by 9.8. And that ends up equaling, if it's hard to figure it out, you could multiply the top and the bottom by 10. So you'd have 490 over 98. And that's 5. So I know my 0 point is 5, so I can draw like a velocity graph here, or velocity line. That's a 10, 0, and 5. And this is where it's 0, and then I can check my values. So if I look at my velocity value over here, when it's 1, it's going to be negative. I'm sorry. When it's 1, it's going to be positive because it's going to be smaller than 49. So I got positive here. And if this is bigger than 5, this will be negative. So I'm moving to the right on this interval, and I'm moving to the left in this interval when the velocity is negative or positive. So that's kind of easy to see. So I'm going right on this interval from 0 to 5. And I'm going left on this interval from 5 to 10. And I've stopped when the velocity is 0. So that's at t equals 5. Okay. So that's the B part. I'm sorry, that's the A part. Let's go to the B part. And we want to find the displacement from 0 to 10. So again, as in problem number 1, v of t equals ds dt. And that equals v of t, which was 49 minus 9.8t. Okay. So I can separate the variables, so I get ds, move this up a little bit here, ds equals 49 minus 9.8 t dt, and then I can take the integral of both sides. And we're going to go from 0 to 10. Now this is going to give me my displacement. So that's going to be on 0 to 10. That'll be my delta S, or my displacement, and that's going to be equal to this integral. And I can integrate this right now. That's not too hard. That's going to be 49t minus, and then I will add 1, so that's going to be t squared divided by 2, and if I divide 9.8 by 2, I get 4.9 again. And this is the integral I want to evaluate from 0 to 10 using the second fundamental theorem of calculus. That's my f of b minus f of a. So when we evaluate this at 10, we get 49 times 10 is 490 minus 4.9 times 10 squared. Well, what's 10 squared? That's 100, so that's going to be 490. So that's just going to be 0. Plus, and then if I put sorry, that should be minus. Okay, and that's going to be Okay, so that's evaluating at that. Okay, so that's going to be, yeah, I'm sorry, that was minus, and that's going to be 0 minus 0. So it works out to be 0. So my displacement was 0 like in the first problem. Okay. Now they tell you that S sub 0, the initial position, if S sub 0 equals 3, what's your final position? Well, your final position will be S sub 0 plus delta S, your displacement, but your displacement was just 0, so it's going to be 3 plus 0, so that will be 3, and that's your final position. So my displacement kind of cancels out. These cancel each other out. So looks like I moved as much right as I moved left. Okay, and then the last part, this is the part that sometimes gets a little messy. We want to find the total distance traveled.